There are more comets that pose impact danger to our Earth than we thought. And this is what NASA has found. NASA scientists say a new study proves there are 7 times as many big and potentially dangerous comets flying through deep space than previously thought. Let's remember that the interstellar comets that were found by the amateur astronomers were basically behind the sun. And they found them because they had telescopes that were able to dip to be able to see what was coming from behind the sun. Because the big telescopes can't dip that far down towards the horizon to see what's coming behind the sun. Now, the study analyzed data from the Wide Field Infrared Survey Explorer WISE telescope, the spacecraft that tracks long period comets, LPCs, that take at least 200 years to orbit around the sun. WISE data showed far more LPCs that potentially pose a serious impact, a risk to our Earth. Previously, the sense was that for every 100 asteroid impacts of all sizes, we get one comet impact. Dr. Joseph A. Knuth, senior asteroid scientist at NASA's Goddard Space Flight Center, told Daily Caller News Foundation, now that we know there are more LPCs for every 100 asteroid impacts, we might have 5 comet impacts instead of 1. Astronomers previously gave broad estimates for the number of LPCs in the solar system, but researchers did not have a good way to detect them since they were obscured by clouds of gas and dust. Gravitational forces can move LPCs back into the inner solar system, potentially putting them on a collision course with Earth. An LPC impact would be, of course, devastating. A comet impact is on average much more devastating than an asteroid impact, Knuth said. Think BBs and bullets versus howitzers and nukes, BB guns against nukes. Now, comets are rarer than asteroids, but can carry more than 100 times the energy of a typical asteroid. An LPC would likely impact Earth at a much higher velocity than other space objects. A higher velocity impact would release more energy and therefore would be worse, Paul Chodas, manager of Center for Near-Earth Object Studies at NASA's Jet Propulsion Laboratory, told Daily Caller. This is offset somewhat by the fact that comets are less dense than asteroids, and the energy release of a comet impact would be less than that of similarly sized asteroid impact if the velocities were the same. The study also determined that LPCs are more dangerous than more conventional asteroids or comets because they are twice the size on average. Yes, a body twice the size has 8 times the mass of a smaller body and therefore delivers 8 times the kinetic energy if all other factors are equal, Knuth said. The impact energy is proportional to the velocity squared. So a comet moving 3 times the average asteroid velocity would impact with 9 times the energy. The potential impact of a long period comet would be more hazardous than that of a Jupiter family comet, both because the long period comets are more likely to be larger and because they follow orbits that would impact a higher velocities, Chodas said. The final reason researchers think LPCs are dangerous is their relative stealthiness compared to other space rocks. Detecting an LPC on a collision course with Earth would be far more difficult than spotting a more conventional near-Earth asteroid. The larger distance of comets and the long orbital periods affect the warning time more than higher velocities. The general larger distance of comets makes the tracking observations less effective since they are angular measurements, and the longer orbital periods mean that we don't have multiple opportunities to see these objects at closer ranges, Chodas said. The distance at which a comet is discovered depends largely on the activity level of the comet. The difficulties inherent in detecting LPCs mean that NASA would likely have far less warning that one was on a collision course with Earth. The comet Siding Spring was detected on a trajectory that would strike the planet Mars in October of 2014, just 22 months after it was discovered. Nothing much you can do about it. if it's that close to us, right? You can't do anything to somehow steer it away from us. Now, since comet Siding Spring was quite active, it was discovered at a distance of 7 AU, about 2 years before it passed very close to Mars, Choda said. A less active long-period comet might be discovered only a year before entering the inner solar system. Establishing a precise trajectory for the comet would be challenging and likely take several months, so the warning time would likely be less than a year. 22 months warning is far less than NASA scientists think they need to intercept an incoming comet. The best way to stop an asteroid or comet from hitting the Earth on such short notice may be to send a spacecraft up to intercept it, but even then, NASA researchers think they would need at least 5 years to construct a reliable spaceship and man it. In case of Siding Spring, that case is a reasonable example. Much less than 5 years is a good guess, Knuth said. Siding Spring came in from a celestial pole and was not spotted until it began to exhibit a coma. A larger body would show a coma at similar distances. Earth is just as vulnerable to LPCs and other space rocks as Mars nearly was to the Siding Spring comet. Earth's closer proximity to the Sun would not make it easier to detect a long-period comet on a collision course, according to NASA researchers. The discovery time is dictated mostly by the comet's distance from the Sun and how active the comet is, Choda said. If Comet Siding Spring were headed for an encounter with Earth, its discovery time would be the same. This is from Andrew Follett from the Daily Caller, and it's on Embedded Reality. You can understand how many times in the past we have had extinction-level events. The last time we had a celestial impact was the extinction of the dinosaurs about 66 billion years ago. And also we've had a comet impact around the Younger Dryas era about 13,000 years ago, and which did away with the Clovis culture of North America, as well as the saber-toothed tiger, the woolly mammoths, the fauna of that time. Please leave your comments, and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.